Here is 10.5, multiplication and division of radicals. So the first thing that we need to tackle is we need to remember how we can break up radicals into separate radical functions. So the same can be applied when we start looking at how we can reverse engineer these. So here, when we multiply these out, we'll have 3 times 5 times the square root of 2 times the square root of 6. Since these are both to the same index, we can write them under the same radical. So we'll simplify 3 times 15. 3 times 5 is 15. And then we have the square root of 2 times 6 within the radical. But we know that 6 is the same thing as 2 times 3, and we already have 2 times there. In this case, we would then have 15 and the square root of 2 squared times 3, which we know that 2 will actually come out, and we'll have 15 times 2 times the square root of 3, which ends up being 30 times the square root of 3. That's how we get that first one. Now, we'll go down to this next one here. We'd have -7 times 2x times the square root of y times the square root of xy. Again, we can write them under the same radical because they have the same index, right? The index is 2, if you will. So we have -14x times the square root of y times x, times another y. So really that's going to be a y squared inside a square root. So that means we'll be able to have a y that comes out of the radical. So we have -14x times the square root of y squared times x. Again, you can break this up to being the square root of y squared times the square root of x. That just simplifies to y. Hence, we can write it as -14xy times the square root of x. And again, that is our final answer for that one. Here we have 15 times 1/3 and times c. And we have the third root of cd times the third root of cd squared. Again, same indexes, so I can write them under the same radical. So I have 5 times c, 15 divided by 3 is 5. And then I have the third root of cd times cd squared. If I simplify that, I'll have 5c and the third root of c squared times d cubed. Well, I have a d cubed inside of the third root, which means simplifies to 5cd, and we have the third root of c squared. And that is our final answer for that. For the more practice problems, I'm just going to fill in the answers so that way you can check them on your own. You should get -6ab squared times the square root of a for this one right here, and 20a third root of b squared for that answer right there. Now, moving on, we're going to expand the way that we multiply them. We're going to think about foiling it, basically factoring it in, distributing it in. So we have 3 times the square root of 11 times 2 plus 3 square root of 11 times the square root of 11. Well, if we simplify that, this is just going to be 6 times the square root of 11. That's this first part right here. This part right here, you'll note that we can write that as 3 times the square root. Since they're both the same index 2, right? I can write 11 times 11, but that's really what? 11 squared inside a square root, which then yields just 3 times 11. So 6 squared of 11 times, 3 times 11, which yes, is 6 times the square root of 11 plus 33. That is your final answer. That one, got off the page there. Now this next one right here, for the more practice, walk through this one real quick. Basically, we distribute in. So the first thing we'll have is 5 times the square root of 5 times 2 times the square root of 5. And then we'll have -2 times 5 times the square root of 5. Let's simplify. This is really going to be 10 times the square root of 5 times the square root of 5. But this is really the same thing as writing this as the square root of 5 squared because we put the 5s under the same radical, which we know the square root of 5 squared is just 5. So we have 10 times 5 minus 10 times the square root of 5, which yields 50 minus 10 square root of 5 as our final answer for that one. All right, down here we have the square root of 5 times 2 times the square root of 5. That's the first part, right? So this one we're basically going to FOIL, right? And then we'll have the square root of 5 times a negative. So we'll say subtract square root of 5 times the square root of 2. And then we'll have this piece right here, plus 3 times the square root of 2 times 2 square root of 5. And then finally, this last piece right here, we'll have a negative 3 square root of 2 times the square root of 2 because of the negative minus there. And now we have 2 times 5 minus, we'll write this square root of 10. This is going to be plus 6 times the square root of 10. This will end up being minus 3 times 2. If we simplify that, we'll get 10 minus square root of 10 plus 6 square root of 10. These are like terms, so we can simplify that. And this will be negative 6. So 10 and 6 give me 4. This will give me a positive 5 square root of 10. And that is our final answer. Now for the next one right here. Again, we would just FOIL, right? First ones. So we have negative 10 a square root of b times a square root of b. And then we'll have the next one, which will be minus 10 a square root of b times 2b. And then we'll have this times this, which will be plus 7b times a square root of b. And we'll have the outer part, which will be plus 14, right? 7 times 2, and then we have a b squared. So just trying to write it so that way it goes there. Now let's simplify. Right here, I have basically a negative 10a squared times b, right? If I simplify that, and then here, we go through this, we'll have a negative 20ab square root of b, and here we have plus 7ab square root of b plus a 14b squared. Well, looks like these are like terms, so I can simplify that. I'll have negative 10a squared times b minus 13ab square root of b plus 14b squared. All right. Now we'll talk about multiplying radical expressions a little bit further. So same concepts. This one's just a little trickier because we have 3 terms inside here and only 2. So that means when we expand it all out, we should have 6 terms. So we'll have, I'm going to write it down here, 6 times 2 times the square root of x. That's our first term. And then we'll have minus 2 square root of x times the square root of x. And then I'll have plus 2 times the square root of x times 8 times the square root of y. And then I go through the next part right here and do those ones as well. So I'll have 6 square root of y minus square root of x times the square root of y. And then finally, the last one, which will be 8 square root of y times the square root of y. And if we go ahead and simplify those, since I'm going to run out of room, I'm just going to write this down here. And we'll have 12 square root of x. Well, we have square root of x times the square root of x. That's just x. So we'll have minus 2x. And here we'll have plus 16 square root of xy, because I'll write them under the same radical because they have the same index. And up here I have plus 6 square root of y. That's this part. And then we'll simplify this, minus square root of xy. And here we'll have plus 8y. Now we collect any like terms that we see. Is there any other square roots of x? Nope, nope. Any other x's? Nope. Are there any? Oh, there's 2 xy's. So we can combine those. So let's just go through minus 2x plus 15 square root xy plus 6 square root of y plus 8y. And that is our final answer. All right. Moving on to this one right here. This is the square root of 11 squared. But we know that basically if you do that, you'll just get 11, right? And that's because we do square root of 11 times the square root of 11. If you write that under the same radical, you get 11 squared inside there, and that just results in 11. So same concept here. If you have the fifth root of something to the fifth power, you just have the inside term, which is your radicand, right? So 4z. Same thing here. This will just be PQ when we have it like that. All right. Squaring radical expressions. Again, let's write this out, what that means here. This means the square root of d plus 3 times the square root of d plus 3. So then when we expand that out, we'll get d, right? Because you'll have the square root of d times the square root of d, which we know will just be d, because it's the same thing as writing the square root of d squared, which is just d. And now we'll have plus 3 square root of d plus, that's this part right here. And we'll have this one right here, 3 square root of d. And then finally, plus 3 squared, which is just 9. Let's simplify that. We got a d. These are like terms here, so we can add those. So we'll have plus 6 square root of d plus 9, and that is our final answer. Same here. 5 square root of y plus square root of 2 times 5 square root of y plus the square root of 2. We can go through and expand that out. We'll get 25y, right? So you get 5 times 5 is 25, and then you have square root of y times the square root of y, which is y. And then we have that last term right there, which we're going to have plus 5 square root of 2y, right? I'm going to rearrange the inside of the radicand. Then I'll have a plus 5 times the square root of 2y. That'll be this term right here. Then I'll finally do the last one, square root of 2 times the square root of 2, which you know is just 2. So let's simplify. Oh, these are like terms right here. So that means we'll have a 10 square root of 2y, and that's just 25y plus that. So that is our final answer there. All right, notice right here, this is a plus and this is a minus. We call this the conjugate because it's the same terms, but instead of having a plus here as well, it has a minus, which you're going to see does a unique property. It drops out these middle terms right here. So we'll have the square root of 3 times the square root of 3. That's this term and this term. And we'll have this one right here, which will be minus 2 times the square root of 3. Then here we'll have plus 2 square root of 3. And here we'll have a negative 2 times 2. Well, what do you notice about these? They drop out. That's the whole beauty of a conjugate term. Basically, they drop out. So we have the square root of 3 times the square root of 3, which is just 3. This becomes 0. And then we have a minus 4, which yields negative 1 as our answer. Now we go through and do the last one here. We'll have 1/3 square root of x. So this term and this term, right? Times 1/3 square root of x, which hopefully you'll see that is 1/9 x. And then we'll have this term right here, which will be plus a 1/2. Oops, sorry. This one and this one right here first. 1/3 square root of x times a negative 1/2 square root of y. That's this and this term. And now we'll have this term right here. So 1/2 square root of y times 1/3 square root of x. Hopefully you see that these will drop out. And then we finally have the last one, which is going to be the minus 1/2 square root of y times 1/2 square root of x. And in this case, oops, sorry, there's a y there, sorry. These will drop out to be 0 because they're the conjugates. And then here we'll have a negative 1/4 y. So in other words, our answer is 1/9 x minus 1/4 y for our final solution there. Now, the next one we have here is the 3rd root of 5 times the 4th root of 5. In this case, we know that they have the same bases, so we could rewrite this as 5 to the 1/3 times 5 to the 1/4. And what we know is that if they have the same bases, we can add their exponents. So we have 5 to the 1/3 plus 1/4, right? And with that being done, we know that we need to get a common denominator between 3 and 4, which is 12. So I'd have 4 twelfths plus 3 twelfths. which ends up being 5 raised to the 7/12. And then we want to write it in radical form, not exponent form. So we'd write this as the 12th root of 5 raised to the 7th as our final answer. Now, that might not work on here because they have different bases. So what we need to do is figure out how we can write them such they have the same, basically, root, right? So if we write this as 7 to the 1/3 times 2 to the 1/2, well, I could rewrite this as 7 to the, well, these common denominator is 6. So I could write this as 2 to the 6th, or 2/6 of 7. 7 raised to the 2/6 times 2 to the 3/6. And what you note now is I can rewrite these as basically the 6th root of 7 squared times the 6th root of 2 cubed. Since they're on the 6th root, I can write them all underneath the 6th root. And then that would be our final answer. You could expand these out as 49 and 8, which I believe is 392. So 6th root of 392 as well. All right, let's go down here. And the more practice, I'm going to do these ones just to try to help. So in this case, we have x to the 1/2 times x to the 1/3. Note same bases. So that means I can just go ahead and add their exponents. So in this case, 1/2 plus 1/3 is going to be x to the 5/6, which we'd rewrite as the 6th root of x to the 5th power. All right, going down here, note we have an x to the 1. Let's just leave that alone and not put it into our radicals here, okay? So I'll have x times x to the 1/2 times x to the 1/3. Oh, wait, we already did that up there. So can we just use that? Yeah, so we have x times x to the 5/6. Well, we know that's x times the 6th root of x to the 5th. Note, if we put that x in there, you'd actually end up with the 6th root of x to the 11th, which is not simplified. This is the simplified version that you'd want. All right, moving on to this one down here. We have the 4th root of x cubed times the 3rd root of y. So we have x to the 3/4 times y to the 1/3, right? 4th root, 3rd root. So that's why the denominators are those. And that means 12 is our least common denominator. So hopefully you'd see that we need to multiply the numerator and denominator by 3. So we'd have x to the 9/12. And we have y to the 4/12, right? Because that'll simplify to 1/3. This will simplify to 3/4. Right? Yep. Now, if we write that as the 12th root, we can write that as x to the 9th times y to the 4th. And that is our final solution. So simplifying form for radical, you guys can read this, but basically the radicand has no factor raised to a power greater than or equal to the index. That's just like what I said here, right? The radicand has a power of 11, which is greater than 6. So therefore that is not simplified, hence why this is the simplified version right there. The radicand does not contain a fraction. No radicals are in the denominator of fraction. This is the next thing that we're going to tackle, which is basically called rationalizing a denominator. So before we do that, though, we're going to just kind of do a review real quick of the division properties of radicals. So if this case right here, if we have the square root of a to the 6th and b to the 4th, this is a fraction within the radical. So we want to simplify this. So we'll write this as the square root of a to the 6th over the square root of b to the 4th. Well, by now you realize that we can rewrite this as a cubed squared in the square root. So that means it's just a cubed. Here we could write this as b squared squared in the square root. And we're left with b squared as our final answer. All right, down here it's a little trickier because we have numbers, but we'll go through it. And we have the 3rd root of 81 y to the 5th over the 3rd root of x to the 3rd. Well, the denominator is pretty easy. It's just x. Numerator, though, is a little trickier. We know that 81 is actually 3 to the 4th, but let's rewrite that as 3 cubed times 3 to the 1. We'll see why we're here in a second, because we'll have 3 cubed times 3 to the 1. That'll just become 3 as we pull it out. And then we can write y to the 5th as y to the 3rd times y to the 2nd. And again, simplifying that, we'd have 3y times the 3rd root of 3y squared over x as our final answer. There we go. Now, the next one is using the division property to simplify radicals. So what do you note here is that they have both the same indexes, except for it's the other way now. We want to rewrite this as the fourth root of 8p to the 7th over p cubed. Why? Well, we note there's a p into both these, right? And that means we can simplify it this way. And so if we note we have the fourth root of p to the third and p to the 7th, which means this should just be 8p to the 4th. But now we note that the p will come out and we'll have the fourth root of 8. By the way, 8 is 2 cubed, so therefore it is in lowest or simplified form. All right, we'll go through the more practice here. So this would mean that we have the square root of x to the 4th over the square root of y to the 10th. The reason why I'm writing this way, these have different bases, so we can't do the same thing that we did up here. We have to do something different. So in this case, this will be x squared, and this will be y to the 5th. Once you simplify, right? Because we can rewrite this as y to the 5th squared. You're taking the square root of it. So those two will reverse each other and you have y to the 5th. Over here now, we know we have a y and both common in the denominator and numerator of the radicals on the quotient. So we have the third root of 16y to the 4th over y. Well, we can rewrite that as the third root of 16y cubed. Well, and that means y will come out. So we'll have y times the third root of 16, but 16 is really 2 to the 4th, right? So we can rewrite that as 2y times the third root of 2 as our final answer. I'm sorry, that got off a little bit off the paper. There you go. Now we're going to talk about rationalizing the denominator one term. So you might be wondering, how do you get this to be equal to this? If you want to type in your calculator, you'll see it's the same thing. We talk about rationalizing the denominator because we want to get the radical out of the denominator. So if you had 6 over the square root of 3, we multiply by the square root of 3 over the square root of 3, what you'll note is that this will become a non-radical. In other words, just a number. And so we have 6 square root of 3, but we note there's a common factor in 6 and 3, which is 3, right? So that's how we end up with 2 square root of 3 for that. This one over here has a conjugate, and we'll do that one here in just a second, but let's go through a couple other simpler things. We want to find the missing radicand to rationalize the radical expression. What we're trying to figure out is what value here will allow us to just get 7. Well, that would be 7. In this case, what we want to figure out is how can we just get it to be t? So what we can do here is we can write this as t cubed in there. And that's because we'd write the 5th root of t squared times the 5th root of t cubed. We write that under the same one, we'd have the 5th root of t squared times t cubed, which simplifies to the 5th root of t to the 5th, which gives us t. The whole idea here is that we're basically simplifying this by getting rid of the radical, like we want to do when we rationalize the denominator. Same thing applies here. We want to figure out how we can just get this such that it's just, let's say, 5x. So what value can we multiply such that we'll have, say, the final terms of the third root of, say, 5 cubed times x cubed? Well, that means we're missing 5 squared here, and we're missing an x. So this question mark right here should be 25 times x. Because if we multiply that by the 5x squared, we end up with 125 times x cubed. Well, 125 is really 5 cubed times x cubed, which when you take the third root of it, will just end up being 5x. All right, rationalizing the denominator. In this case, what we want to do is get this such that the final answer just has an a down here. So the third root of a squared will allow us to do that. And again, we multiply by 1 like this, we'll have 5 times the third root of a squared, and that is our final answer. You'll note that if you do this, this will be the third root of a cubed, because a times a squared will give us a cubed. Here's a little simpler. We have the square root of y to the 5th over the square root of y to the 7th. So that means we need to multiply by the square root of 7 over the square root of 7. That'll give us just 7 in the denominator. So moving it down here, we'll have square root of 7y to the 5th over 7. We still need to simplify the numerator part. And this is a square root, which means this should be y squared times the square root of 7 to the y. Sorry, yep, 7 to y to the 1 over 7. The way we do that is y to the 5th can be written as y to the 4th times y to the 1, which is really just the same thing as y squared squared. And if you're taking the radical of it, this part will come out. Over here, we have 15 over the third root of 25s. So what we want to do is get it such that the final answer just has maybe a 5s down here, i.e. that like this simplifies here. So if I multiply this by the third root of 5s squared, because this is already 5 squared, so therefore if I multiply 5 and 5 squared, I get 5 cubed. And once I do that, we have a 5s down here. We go through and multiply that out. I'll move this because we're running out of room a little bit. So we'll have 15 times the third root of 5s squared over 5s. But we know there's a common factor in 15 and 5, which is 5. So therefore we get 3 times the third root of 5s squared over s as our final answer. Finally, the last thing is rationalize the denominator 2 terms. So this is like that first example. This is where we're going to use the conjugate property. Basically, it drops out that middle term. So if we multiply this by 2 minus the square root of 6 over 2 minus the square root of 6, put our parentheses in there, right? Because if we don't, then we won't know that we have to distribute everything. If we go through and multiply that out, we'll get 2 times 2, which is 4. Then we'll have a positive 2 times a negative square root of 6. That's this term right here. This one right here, I mean. And then we'll have this part right here, which will be 2 times the square root of 6. And there should be a plus there. And then we'll have minus the square root of 6 times the square root of 6. These terms are the same, but they're opposites, so they cancel out. This will be negative 6, and this will be just be 4. So we have 4 minus 6 in the denominator, which is just negative 2. Up here, we'll have a negative 2 times 2, and we'll have the negative 2 times the negative square root of 6, right? And in this case, we'll end up with a negative 4 plus 2 square root of 6, but there's a common factor of 2 in the numerator and denominator, or negative 2, let's say. So we'll see that basically this is the same thing as 2 minus the square root of 6 over negative 2, and we're left with 2 minus the square root of 6 as our final answer. Moving on to this one, the conjugate of this is the square root of x plus 7 over the square root of x plus 7. That's because when we multiply these out, the middle terms will drop out. So if we do the first term, square root of x times the square root of x, that'll just be x. And we do 7 times the square root of x, that's this next term. And finally, we'll do the minus 7 times the square root of x. And the last one, which is minus 7 times 7. These are opposite, they cancel each other out. And so we're left with x minus 7 times 7, which is really 7 squared, which we'll write as x minus 49 in the denominator. Now let's move up to the numerator. Again, put your parentheses in there just to remind yourselves. I didn't do that down here, but that way you know it distributes through all of them. So the first one we'll have is 4 times the square root of x. And we'll have 4 times 7. Then we'll have the square root of x times the square root of x. And then we'll finally have plus 7 times the square root of x. All right, let's go ahead and collect like terms. So we got a 4 square root of x and a 7 square root of x. So I'll write that as 11 square root of x. Then I have a plus 28. Then I have square root of x times the square root of x, which is just x. So my final answer is x plus 28 plus 11 square root of x. And that's it. Down here, again, put your parentheses in there. Don't forget that. And we have the square root of 2. Remember conjugate, so that means this should be a plus. 4 square root of 5. So we have the square root of 2 plus 4 square root of 5. Parentheses in there as well. Let's go ahead and, well, I'm going to skip doing the whole bottom out because you know that square root of 2 and 2 is 2. We know that the middle terms will cancel out. So I'm only concerned about that last part right there. This is important here. This will be a negative 4 times the square root of 5 times 4 times the square root of 5. Well, that's going to be negative 16 times 5. Okay. And that's going to be negative 80. And now we do the numerator part, and this is different. So we'll do 3 times the square root of 2 times the square root of 2. Then we'll do plus 3 times the square root of 2 plus, no, not plus, sorry, times 4 square root of 5. Plus now 2 times the square root of 5 times the square root of 2. And then finally our last term, which will be plus 2 square root of 5 times 4 square root of 5. Yes, it's really long-winded right there, but this is just really, we'll simplify this right down here. Our denominator simplifies to negative 78. Up here, we'll have 3 times 2. Here we'll have plus 12 times the square root of 10. Here we'll have plus 2 square root of 10. Here we're going to have plus 8 times 5. If we simplify things out, we get 6 plus 14 square root of 10 plus 40 over negative 78. And in this case, we just collect like terms, right? So the 40 and the 40 and the 6 become 46. So 46 plus 14 square root of 10 over negative 78. There's a common factor of 2 in both the numerator and denominator that we can simplify out. And we'll have a negative 39 in the denominator, a 7 square root of 10. And then this will be 28. And that is our final answer. And that's it.